Cool. Let's get started. You guys can hear me, right?
Yeah.
Cool. So first of all, thank you all for attending. It's a pleasure to have you all, and really appreciate because it's the weather is not really, helping us, and I wish to make the most of it. So also, I would like to first thank you, Mario Weigel, as well, to keeping this organized very smoothly. And last but not least, a massive thanks to Microsoft for hosting this. And I'm Mario Fernando. I'm currently a chapter lead at ASB Bank, Auckland Savings Bank. So I come from years of experience with running Kubernetes production workloads over a decade. And so I have been working with massive fintechs like Wise or TransferWise and airlines such as Air New Zealand as well. Also, I'm a Linux Foundation authorized instructor for providing Kubernetes certification training and Linux kernel performance tuning. And let's get started. Site reliability engineering?
SRE.
Yes, I'm an SRE. Yeah, in the SRE scope, that area.
What's SRE stand?
Site reliability engineering.
That's good.
SRE stands for Site Reliability Engineering. Yes. Yeah.
It's a Google concept.
Yeah.
It's their version.
Yeah. It's like, okay, cool.
They needed a 3-letter acronym. They chose it.
Yeah. Cool. So today, the agenda, it's mostly, I would say, I will talk about progressive delivery, or in other words, Canary analysis, right? Anyone is doing Canary analysis in production, Kubernetes production? Raise your hands. Okay, okay, okay. That's just a handful. So I hope this demo helps. Right, and we can also talk about the history of Canary and blue-green deployments. And so we are going to use GitOps, right? So Argo CD is the tool, well-known tool. We have Flux and other tools as well in the cloud-native ecosystem, but we'll be sticking to Argo CD. And then Argo rollouts, it's another, well, a CRD from Argo, right? And for the service mesh, we will be using Istio, a very popular service mesh. And to gather metrics, pull metrics from the service mesh, we'll be using the most popular open source tool, pull-based metrics tool called Prometheus. I'm sure that you are familiar with that. And a bit about Canary Flow and Canary Analysis. So 3 demos presented today. Manual promotion of Canary deployment, right? So, and then I'll proceed with automated promotion of Canary deployment. So the automated part will be relying on more intelligent metrics-based promotion. And last but not least, a rollback scenario. If you introduce a buggy app, how are you going to roll back to the last stable version of the app or the API? Right, so moving on. This is the solution overview, right? So pretty much a very familiar weave of our day-to-day platform engineering or DevOps, SRE, whatever you call it, right? So from the top, if you see a customer, right, a stakeholder accessing through the internet an infrastructure, right, an application which is running inside Kubernetes, we got the AKS cluster. Let's see whether I can move on. Yeah, so it's working. AKS cluster is there, and north-south traffic is basically, which is like, coming from the internet towards the cluster. We have east-west traffic as well, which we'll not really be discussing on today's scope. And we'll be exposing Istio, right, as an ingress control as well through an Azure load balancer. And the most prominent components in here are, we've got Argo rollout CRD. So instead of Kubernetes deployment object, we'll be using Argo rollout CRD. And I will tell you why we are going to use that. And we'll be using Argo CD, which is running inside the cluster as well. And so we have the Canary here, which I'll again deep dive later on. And of course, the Argo rollout object will use Prometheus metrics, right? Kind of monitor that and bump the bump the traffic ratio 90-10, 80-20, likewise, right? So Argo rollouts does the job. And then there's a component called, well, another object in Istio, a virtual service, where this will bump the traffic, right? So all based on Prometheus, it's going to intelligently split the traffic, right? This is just an overview, but I'll be doing a hands-on demo, so you could understand more on the details precisely. Cool. So I'll get to the demo right away. Just a moment. So, right. Are you able to see your screen once at the back? Is it too small? One more. Okay, all right. I'll try my best. How about now? Yeah. Okay, cool. Right. So, right. So prerequisites, right? A Kubernetes cluster. I have already created one just before the demo. I don't want to, spend time creating a Kubernetes cluster, which spans across, 10 to 15 minutes. And then we got Helm and kubectl configured. I have already configured that. And then Argo CD deployed, Istio deployed, Prometheus deployed. I haven't deployed them, but I'll just run through probably, by just copying, pasting the commands just to show what's done there, right? Right, so let's get started. So the first step, Kubernetes cluster is all done, right? Cool, I'll just show you the clusters. So currently, I have a cluster called demo 3, right, which I'll be using. Demo 1 is like a backup cluster, which I have set up everything, just as a backup. In demos, anything can happen. Right, so next, what I'm going to do is, let's see the nodes. And by the way, I've set up aliases. So K stands for kube control, right? So we just have one node. By the way, in production, do not recommend this. Of course, you need to have a highly available setup there. And let's just copy and paste these commands. Just get this. So in a nutshell, what happens here is it's adding the Helm repo for Istio, right? And then runs a Helm repo update. It's like yum update, apt update, right? Then it creates a namespace called Istio system where we are going to deploy all the Istio's brain, the service mesh's brain, Istio-D, Istio daemon. And then we are going to install the Istio base components, the CRDs as well. And of course, because we need to expose whatever which is running inside Kubernetes to the outside, we have different options. You could use Nginx, Traffic. Nginx, I think one of them is almost, retired, right? But for simplicity, we will be using Istio Gateway. It's not a very common use case, but for the purpose of the demo, we are going to use that, right? So I'm just gonna copy paste this. It's not easy to, the font is too big, so. So that's basically the CRDs. And if you see the containers got created, right? So if you see, they came up, that's the watch command, right? If you can see real-time stats or the replicas coming up and readiness probes coming into light, right? So it's there, cool. And next, moving on, right? So I'm going to demonstrate what happens exactly, right? On the diagram. Right, so service mesh, right? So back in the days, developers, so let's say I want to encrypt the service-to-service communication between two services. And then what happens there is the developers need to write code, instrument code to make it happen, right? It was an overhead. Developer experience was not, well, it wasn't a popular way of doing it back in the days, 5-10 years ago, right? That's why we have the service mesh concept, right? So we offload those pain points within the instrumentation of the code to the outside service mesh, right? So this is a dedicated infrastructure which could be deployed. And what happens here is, right? So if you see Istio-D, the brain of the service mesh, it's called control plane. And then we got two services, let's say two microservices, right? A shopping app, maybe this is the front end or back end or whatever, right? So all the traffic, it always goes through the proxy, and the connection or the traffic is all MTLS, mutual TLS, right? So it's all, I think it uses symmetrical encryption. The certificate rotation, expiration, everything is all automated using Istio-D, the brain of the service mesh, right? And so I'm sure that you know what is GitOps, right? But just as a refresher, there's a cluster, and the Argo makes sure whatever which is there in the source code is in sync with Kubernetes. If someone does a manual change in the Kubernetes cluster, Argo makes sure it's reverted and it is all 100% in line with the source code, right? Cool. And this is how the service mesh kind of operates. This is the very simplistic view of how a service mesh operates, right? So we got the brain, Istio-D, service mesh controller. I'm going to do the demo, the demo in a namespace called demo. And basically, Istio will then inject sidecars, whatever, which is running in that namespace. And if you see, we have pod 1 and pod 2, right? So when we label, add a specific label to the namespace, Istio controller will automatically add a sidecar, right? So because a pod is a logical collection of closely related containers. So this pod will have two containers, the Flask API. And I forgot to mention the API, which I will be, actually it's an API. Yeah, you can call, it's an app, right? And it is a Flask app. For simplicity, I use that, so a few lines of code there. And Istio sidecar is basically the one which controls traffic, which does the MTLS, which does the circuit breaking. That 9 to 10, 90-10 ratio, which I showed in the diagram, is all done using Istio, right? And on the other hand, right, we have Prometheus, which is another, a deployment which pulls all the metrics from this Istio sidecar, stores it so that those metrics could be analyzed by Argo rollouts to bump the traffic 90-10 likewise, right? For example, let's say this is pod 1 is the stable version of a software in production. Pod 2 is like a new version, right? And for some reason, pod 2 has some issues, right? And then what happens here is Prometheus will store all the HTTP codes using Istio metrics. So let's say this is returning 200s, but pod 2 is all returning intermittent 500s. It could be 200s and 500s, a mix, right? So does it mean that we should switch traffic to pod 2? No, right? We need to kind of make it 100-0, right? 90-10. So that's why it's important for us to pull metrics out of the Istio sidecars. And I'll get back to this later, right? So back to the Visual Code editor. So I'm going to show you how the sidecars are injected, right? So basically, it creates a namespace called demo, label the namespace using Istio injection enable. So sidecars will be automatically attached to the pod. And then I will show the labels, and I'm going to run a test engine export just for demonstration that the container is injected, right? So I'm just going to copy paste. So if you see, there's an Istio init container, which is, what's an init container? Which this is the first container which runs at startup when a pod starts, right? And it's an optional thing, of course. But if you see Istio proxy and test, those are the two containers, right? So kgit pod test, demo. See, 2 out of 2. So it has two containers, right? Istio is there inside that, right? So we got, we have enabled this namespace to have Istio sidecars, right? And let's also check the public IP of the Istio Azure Azure. I think it's an NLB. Let me just show you what that public IP is. This one. So this has that public IP because we are using a load balancer type Kubernetes service, right? Not a cluster IP. So what happens is in Kubernetes, there's a cloud controller manager which talks to Azure saying, okay, I need a load balancer. And this is the IP which was retrieved from Azure, right? So cool. Right. So next, I'm going to install Argo rollouts, right? So I'm going to talk about what's the difference between a deployment and a rollout, right? Right. So Kubernetes deployment, right, is basically it runs some image as a container within a Kubernetes cluster, right? Images, a pod is spawned through a replica set, right? And when you, let's say, when you're running a software, let's say it's 1.0, and when you upgrade it to 1.1, then a new replica set is created, right? So this is 1.0 version of software, and then this is 1.1. And according to the configurations, let's say we got replicas 3 and max surge 1, right? So what does it mean is, on top of the expected replicas, it is allowed to create one more on top of it, right? So here we have total 4. This is 1.0 software, this is 1.1, let's say, right? So, and Kubernetes ingress usually sends the traffic to Kubernetes service, and whoever the user which is accessing the ingress will see a mix of traffic, right? It might be 25% traffic to each of the pod because Kubernetes service, it's using IP tables probability algorithm to load balance the traffic, right? That's how Kubernetes services are usually does the work, right? It's using a random probability module, right? So the good thing about there are lots of good things about deployments, but automatically switching traffic per se in terms of percentages 90-10, 80-20, that capability is not really embedded in here. So therefore, we are using Argo rollouts, right? So similar to deployment, Argo rollout CRD is there, and pretty much it supports all the spec parameters like readiness probes, liveness probes, and everything, right? Almost the same. It's an Argo project, right? And there are different strategies you can say. Canary, blue-green deployment. For today, I'll be just demoing the Canary deployment, right? So if you see, it's different than what we saw before for deployment, right? And it does Canary analysis using Prometheus metrics, right? So here, let's say this pod is problematic. It's a buggy one, right? So I don't want the traffic or the customer having a bad experience. So this Argos rollout CRD is intelligent. It reads the metrics and it will switch back the traffic to the healthy pods, right? That's how it works. But some users might, experience a slight glitch because there's a 90-10, right? Few of the users. That's the trade-off, right? Cool. So I'll get back to. Hope that clarifies Argo rollouts and deployment. Yeah. So let's get going on with this. Basically, pretty much the same. Installing Argo rollouts, creating a namespace, and Argo CD. It's installing Argo CD as well, right? Let's give it a minute. Yeah, and while it happens, Argo CD's admin password is stored as a Kubernetes secret in base 64. So let's just decrypt that. Yeah. Cool. So this is the password, and I will port forward. Later on, I'm going to access the Argo CD UI using the Istio ingress controller, which is another step ahead. So just use, right? So I'm going to use this. Yeah, so of course, self-signed cert, right? Because we are not using any legitimate certificates there. And the password. Right, so this is a fresh installation of Argo CD, right? There's nothing, no app of apps, no application sets, nothing there. It's all empty, right? Right, cool. So next, we are going to install Prometheus, right? A very crucial part of this setup. So again, I'm just gonna copy paste, right, the commands in here. Yeah. Right. While it happens, I'll also install a component called Kiali, right? So we know Argo rollouts does the job for us, splitting the traffic 90-10, whatever, right? But it's good to have that visualization across what exact percentages are split across the entire service mesh infrastructure. For that, I think this is probably from Istio itself, but now it's a separate project, right? So I'm going to install Kiali as well. Yes, so right. So yeah, so it's in Istio system namespace, right? Cool. Right. So next, we have two repositories which we'll be working on. I'll show that in this, right? Right. So one repository for the Flask, Python Flask app, right? And another repository to deploy this app inside Kubernetes, we are using a custom Helm chart, right? And what happens here is under the hood, it's pretty straightforward. For the CI, continuous integration, we are using GitHub Actions, right? And it builds and pushes the image to a Docker registry. And on the other hand, the Helm repository it has two directories, one called Argo CD, which will basically, it is storing the application CRD manifest, and another directory called demo app. Basically, it's a custom Helm chart, which will have a chart.yaml and a values.yaml. I think it might be helpful if we go through the entire GitOps flow, right? So if you see the numbers here, building, pushing image, right, which is done by GitHub Actions on the demo app, and the Helm repository is being cloned by the pipeline of this first repository, right? It clones it, updates the chart.yaml file in here, and then updates the Helm values files too, and then it commits to the branch. This is, I will tell you honestly, this is not a really production grade one because we don't want to push changes to main branch, right? For the purpose of the demo, I will just push it to main branch, but of course, this needs to go through a pull request peer review process, right? So basically here, pushing image, and then there's a PR review, you get comments and fixes it, and then once you merge to main, only the rest should happen, right? And if you see, the last step, so once the code is merged to the Helm repository, Argo CD sees, oh, okay, there's a new change, there's a new commit on a given branch, main or master, or whatever the branch which Argo is configured for, it syncs that particular new the manifests into the cluster. So that's the flow of GitOps, right? Yeah. So I will just yes. So next, I will go through the Helm charts. Okay. Before that, I think it might be helpful. There's a lot of diagrams and stuff because this is a bit, you know, all the components are working all hand in hand. So it's best to have them visualized using a diagram. So here, this is the main solution, right? So if you see, we need Prometheus deployments, and then we will need the rollout object, right? Templated as a in YAML, right? The rollout object, and then we need Istio virtual services, right? One service probably, and then we need 3 virtual hosts, 1, 2, and 3 for the app. Because we need 3, we have 3 UIs, right? Prometheus, Argo, and the Flask API app. So we'll need 3 virtual services there. And yeah, so basically all of this, I didn't want to use kubectl apply minus F, but rather have a Helm chart and use Argo CD doing the job for us, right? So here, so if you see, I'll just, not sure, are you able to see this, right? But I will just get this. Right, so chart.yaml, as usual, this is basically storing all the information related to the chart. The name is demo app, right? There's versions and likewise. And the templates is the most prominent directory, which holds all the objects which will get deployed in the cluster, right? So I'll go one by one. So service table, right? We have one service, Kubernetes service, to send traffic to the stable version of the software in Kubernetes, right? Basically that. And then if you see, there's a values.yaml. So if you see values.services.port, right? I will not go through all the configurations. I just want to show 1 or 2 configurations so it will make sense to you guys, right? That's that service, right? Values.service.port and target port, right? So it's all templated here, right? And for the Canary, same. So basically there are 2 services, demo app stable and demo app Canary, right? And the next is the rollout object, very important. That's one of the things which does just pretty much does the job for us, right? It's from Argo project. It's a rollout CRE, right? And see, it's the Canary service is demo app Canary. Remember what we talked here? Demo app Canary and demo stable. So rollout is sending there, right? And basically the rest is basically, pretty much a specific configuration there. And what else do we have in terms of, yeah, I will just check values.yaml.
Can I ask, is that a direct placement to a deployment? So you don't need both?
No, we don't need deployment object at all. So that's why one of the steps was to install Argo rollout CRD before.
Difference between application and this rollout. Like, do you need both of them, or can you replace the Argo CD application to use Argo CD rollout instead?
So Argo CD is used for GitOps, right? To sync the repository. Rollout
creates application.
Yes, it creates the application CRD, right?
Recreate it.
Yeah, we need to create it by hand, right? So I will need to create it by hand manually.
Also, it's part of, or it doesn't replace the rollout, basically, the application. It manages it.
Yes,
okay.
It kind of manages the rollout object, right? So if we need to do any new changes, you will use version control, that demo Helm repo, and then Argo CD will automatically apply the changes, right? Yeah, something like that. So the deployment strategy is Canary. And so if you see here, the steps first we'll send 10% of traffic to the Canary. It will pause here. That means indefinitely it will pause, send 10% traffic, and we need to manually promote the deployment. It means it will get bumped from 10 to 50 after that. And it will pause for 30 seconds, and then it will bump to 100. That's the one which I am going to demo in few minutes. Right. I don't want to bore you with all the details, but again, sorry with that. I just probably need to open this in here. Yeah. So if you see, this is the key part. Virtual service stable will get 100% of the traffic, and a Canary will get 0. So this is Istio virtual service, and the analysis template which we are using is basically this is the metric which we are going to monitor. Istio request total, which Prometheus pulls from the sidecars, right? It will monitor for the 500s, and it will monitor the total request, and it needs to be greater than 99%. So it means we are expecting only 1% of 500 traffics for 500 requests, 500 returns, right? So that is configured. If you see success condition, right? Values.canary analysis.success. It's in the Helm values file, and I have configured that at somewhere. Here it is, 0.99, right? Yes, cool. And what else do we have for the gateway? Like I said, which basically, sorry about that. Too many windows. Gateway. This is the one which will basically expose the app to the outside, Prometheus to the outside, and Argo CD to the outside. So we don't need to use port forwarding anymore. We will be directly using the ingress controller to access them. And rollout, blue-green, template, virtual service. Yeah, so that's pretty much it. Let's proceed to the next steps. Right. So I'm going to run a Helm template command, right? So basically, Helm template command here is going to read the demo app, this directory, right? And it will write it to a YAML file. So there, basically, service, yes, whatever which was there in C in here, Helm will use the values.yaml file and will replace all the variables. This is just for demoing, to understand how it works. Services, demo apps table, services, right? And then we get Argo analysis template, and 0.99, see, it got replaced using the values.yaml. And then what else do we have? The gateway, and I'm using 3 hosts, demo app, Prometheus, and Argo demo. We don't have any SSL certificates, so we are using TLS mode, pass through, right? And the rollout object, pretty much what we discussed, is all the YAMLs which we already had in the templates directory. It's just templated there, right? So next, okay, now it comes to what Mojib asked, the application. We need to create that manually, right? So, but usually we would use a pipeline to do that, right? But in this case, for the demo, I will be just creating that manually, right? And let me go through the application YAML as well. So application CRD. So Argo CD reads this kind of CRDs, right? So here what it says is, please read this repository, right? Let me just expand that. Argo Canary demo Helm repository head, which is the main in this case, and this path, right? And it will deploy into Kubernetes.default service, because Argo and everything is running in the same cluster, right? So that's why we use this, right? Kubernetes.default.service, Kubernetes service in the default namespace, right? Namespace is demo, right? And I wouldn't go into the other details, which we can probably discuss later on. And I will come back to this ignore differences. What does it mean, right? Later on. Yeah. So let's get this rolling out. Cool. Right, so we got the demo application created, right? Let's see. Yeah, so if you see, we got one created, right? And let's go to the Argo CD UI, and it should, yeah. You can see it's all progressing. It's, if you just click this, all the objects which you saw in the templates directory gets created, right? And demo app replicas, 2 replicas running. If you see, this is the replica set object, right? And yeah, right. So next, I'm going to check demo namespace. It should show to pods. Actually, I will delete this test pod. Would be confusing. Cool. Right, and then let's replica sets, right? So we just have one replica set. If you see 5FF, it ends with 8668, right? If you see the pod names, see, it's the same, right? The replica set ID, right? So basically these pods are spawned from this replica set, right? Cool. And cool, we don't need this for now. Right. Okay. So now I'm going to access the API, Flask API, through the through port forwarding, right? So localhost 8081. If you see, we are currently running some version. It's saying from version 47. It's a random one. 5 minutes. Right. Cool. I'll just, we are running out of time. So right. Okay, let's get the I'm going to get the public IP. Right. So I'm going to access demo app using the ingress control now. Yeah, it's all there. And Argo CD might, yeah, because it's now we are using the ingress and Prometheus as well. Okay. I'll get the secret soon. It and I'm accessing the KRL UI as well using port forwarding. Right. I'm going to show how the traffic will distribute. So I'm going to run a while infinite loop, sending traffic to the web application, right? So it's going to run, okay, it's running a lot of requests, right? So if you see, it's showing, right? Now what I'm going to do is I'm going to upgrade from version 47 to 48. So basically, I'm updating the application, releasing a new image, right? So what I'm going to do is right. So there's a pipeline which runs, which will get triggered. If you see, it's building the image, and it will push to the Docker registry. And what we are going to do next is I'm going to sync this to the cluster. So that image will get deployed to the cluster. Okay, so next, I'm going to show so the Canary replica sets. If you see, we had only one replica set, and there'll be another replica set now, right? 75, right? It just came up 6 seconds ago, right? And demo app Canary is using the 5FF, which is the old replica set, the old image, old software, right? And then stable, yes, it's using the 5F1. And so if you see the traffic's 9010 now, right? 9010, it means if I check this UI, oh, sorry, not this one, yeah. So if you see 48 came up, right? So it means 9010 and the Kiali UI will show you. See, it's being shown. I'll take last 1 minute. Yeah, so basically that's that. Since we have limited time, I'll just jump into the next one. And if you see analysis run, yeah, so successful. And if you see suspended, because we have asked the configuration to like told the Argo rollout to indefinitely suspend it. So I'm going to promote this in here. Rollout object, promote full, right? Yeah. So if you see, and then this should get ideally not needed 100. So it's all the traffic is going to the new version, right? Right, and next. So we did all of these. Okay, so next, the last part of the demo, automated promotion demo. I'll just jump into that very quickly. So since the app repository bumps the Helm chart, I need to probably use the latest one, and I will comment out this part. Comment this part and commit. Push the changes, and then I'm going to sync Argo. Oh. Right, it's done, and then I'm going to release a new image. Should take a minute. 49. Then pipeline should trigger a new one. Yeah, 49 stable. It's already in the build. It should take like 30 seconds for this. Right. There's a glitch. Okay, I'm going to sync this back. And so here, what happens here is it's sending traffic 10% initially, pause for 30 seconds, runs the Prometheus analysis template. If it's successful, then bumps the traffic distribution to 50%, pauses for 30 seconds, and then finally again runs the analysis template. And we could look at that. So we are on, did I click on sync? For some reason, do we have enough time, Mario? Or should I maybe? Okay, so I'll probably hand it over to. Okay, yeah, yeah. Sorry about the delay. Yeah.
All right, so welcome to Developer Experience Engineering. So this is kind of my attempt to summarize and create a way to think about design for people who more traditionally think about like systems and technical things, to now move into thinking about how those work for people and work within systems. So a bit about me, I'm John Cave. I got my start in computers. I learned how to computer by connecting old computers together, making them web servers, making them email servers, sending emails to myself. That's how I learned to computer. I'm also a factory gamer. Do we have any factory gamers in the room? Oh yeah, one. We won't judge you too harshly. Two. So I'm definitely that sort of person that I think about systems and technicals and how things work together. So a few years ago, when I started working with Kubernetes, I started thinking about how do we make this like more approachable for developers and easier to use. And of course, my approach was to start building a system, a tool. I started writing CLIs. The conclusion I came to is that essentially this is actually a whole discipline on its own, which is developer experience engineering. So I'm now an independent contractor. I got my own company. I do cloud DevOps SRE, but coming from that perspective of how do we make this something that works for the developers and the people and the company. So developer experience engineer, would anyone like to attempt to define developer experience engineer? Oh, yeah.
I guess it's just be able to use systems, but making the developers' lives easier.
Yeah, that's a decent approach. There's not really one right answer. We've got some developer experience engineers here. Would you guys like to try and define? Yeah, I like that. That's quite good. Yeah. Yeah, I define it. We've got user experience engineer. That's quite a very well-known role in our industry. So it's user experience engineer for developers. When I realized that this is a whole discipline on its own, I kind of looked for systems and approaches that already exist. And what I sort of found is that they kind of cover the what, but not the why or how. There's kind of, make the system easier to use for developers. It's like, well, okay, great, fabulous. So what I did was I went back to basics. So this book is The Universal Principles of Design. I highly recommend picking up a copy. It's basically the Bible of design. It's got things about obviously like fonts and spacing and colors, but also about like more engineering and like getting into details and how to build something. So what I did was I went through the universal principles of design, and I've kind of assembled it into a system that I'm hopefully going to teach to you today. So let's get right into it. The 80-20 rule. So the 80-20 rule is kind of like a rule of the universe. There's all sorts of examples, like you'll probably find that about 80% of the page views to your app go to about 20% of the pages or features. 80% of your company's revenue probably come from the top 20% of customers, all sorts of things like that. The biggest example that I always heard was the first 80% of a project takes 20% of the time, because as soon as you get beyond 80%, you start running into, oh, we've got to redesign the whole database because there's a feature that no one told us we needed. So how to use this for developer experience engineering, flipping that rule on its head, right? What is the 80% that we can build in 20% of the time? And what is the 80% that developers actually need and use? This is what I call the 3 C's. And this is kind of one of the big lessons I want to teach you guys today, is how to like use and think about these and how to apply them to different systems. So consistency is the top of our top of our triangle. That is consistency of the environment and the tools and the systems that your developers are using. It's also maybe across different companies. So you don't want a developer to come from one company and move to your company, and you've got a custom programming language. They're not going to know how to get started, right? Control is getting out of the way and letting the developer do their job, like giving them the tools that they need to actually get in and do the technical work that they need to do. Don't forget that you're a developer, and think about your control, so your ability to like reach and override them when you need to. Constraints is where you limit that control, right? You don't give them free rein to do whatever they want. So often security and access controls kind of come under that, but also like things like code scanning and static analysis tools, like making sure that they're not doing something stupid. You also get constraints that are like external, right? Like organization. If you are within like a massive company or a 2-person startup, you're going to have very different external constraints. So I want to teach you guys how to use this triangle, and we're going to use very classic example, very simple example. We're going to use operating systems, right? So Windows, Mac, Linux. Where would we put them on here? So let's start with Mac for a reason. So what would we give Mac for consistency? Would we put it way up here, high consistency, or over here, low consistency? Someone's just shouted out. High, yeah. Yeah. So gave it high. What would we give Mac OS for control? Would be over here, right? Everyone agree? And constraints, also probably high, but maybe not as high as consistency. So maybe over here somewhere. Would that be fair? So doing the same for Linux. What would we give Linux for consistency? Would it be high or would it be low? No, yeah, we've got different operating systems. Some of them use different standard tools, different desktop environments. Very low consistency, right? What about control? High, yeah. Constraints, any constraints? Yeah, we can introduce consistency and control with like external tools, but Linux itself pretty much right over here, right? And so that is where you want to put things, and how you analyze them on the 3 C's triangle is very context dependent, right? So a desktop OS, we probably want to be somewhere around here, right? A server OS, we want to be able to do whatever we want, deploy our software, run whatever security protocols we want. So would we say that Mac and Linux are in the place that they should be on the triangle. Probably a difficult question. Well, exactly. That's what I'm trying to say. I guess it depends. So with that in mind, let's move to Windows. So what would we give Windows for consistency? Oh. Yep.
Are you talking about between the three where it lies? Or
Yeah, so I'm talking about, so we've sort of got a triangle of trade-offs, right? We can make, are we doing a really consistent experience? Are we doing a really constrained experience? Or somewhere in the middle, right?
because like to me, if you've got 3 points, it can only be in 1 point, not 3 points.
Yeah, I'm talking about like the triangle, where within that triangle are we?
So a Mac basically will be almost
Some-
in the middle, slightly higher.
Somewhere here, yeah,
Oh,
or
okay.
some versus somewhere here.
You move it around between, and I'm like, not
Okay,
understanding.
yeah. I'm probably
Now
going a bit
it's
fast.
input.
Yeah. So yeah, I guess where would we put Windows? So would it be high consistency way up here, or would it be low consistency down here? Anyone want to hazard a guess? Lowish? Yeah. So the thing with Windows, right, you're saying it's low consistency, but for enterprise, I can reach in and I can say, you have to have this desktop, you have to have these tools, you can't use UAC. Group policy lets me reach in and do literally anything. So you get a very consistent experience.
That's marking out the control, not consistency.
Yeah, so that's giving me control to, so yeah, there's two things happening here, right? One is that this is what happens to projects over time, because Windows is, don't forget, been an ongoing project for 40 years. Projects get pulled in all these three directions as they go on, usually towards control. It's not often that someone will come to you and say, we need to increase the constraints of our system. It'll pretty much always be towards control, and it'll often be your job to say, well, these are the constraints that we need to make if you're going to give people that control. The other thing is that these are kind of the tools that you have to use as a developer experience engineer, like group policies, access controls, static analysis. And it's your job to figure out where you're going to place your developers on this triangle using those tools. And Windows gives you the control to do that. So I'm going to come back to this, but let's move on with our principles. So cognitive load. It's often said that someone can only have 5 to 7 things in their working memory at once. Your developers have the whole code base. They've got the bug that they're working on. They've got how that interacts with everything else. They've got the deadline of, I have to show this to my boss tomorrow. So you maybe only have 2 or 3 slots left in their working memory. And you have to leave space for everything else. I'm going to take you through a really simple example. You've asked Claude to install AWS CLI in one of your pipelines. This is what it will always give you. So can anyone see what's wrong with this? In a pipeline, you generally have admin access. I'll give you a hint.
Anything.
Yeah, we're not really thinking in terms of security, just in terms of cognitive load, I guess. I mean, zero in on this line. Does that help anyone? What is the default behavior of unzip? Yeah, so kind of. This is what unzip does, right? It outputs every single thing that it's doing into your pipeline. So when your developers come in like, oh, my code's not running, why not? They have to scroll past all of this, and that pushes something out of their working memory before they can even start debugging what's going on. So real simple fix, how would we fix this? Yeah, so we can use unzip-q for quiet, right? And then it's gone. So I'm just kind of trying to say that design doesn't have to be like a massive thing. It can just be little tweaks and little improvements that you do every day. Can anyone see the second layer of cognitive load that's going on here? So first of all, unzip doesn't support like -- quiet. It's all of its options are like single letter flags. So it's forcing us to learn its own esoteric options. It's also like, it should be like not the default that it just outputs everything, because like, why would I ever want that? So it should be the opposite, unzip -v if you want. That's all I'm trying to say. So immersion and iteration, this is two more principles from the book. Immersion is where your developers are locked in on their task, got their headphones on, working on what they're doing. You want to keep them in that state as much as possible by not surprising them with like random output from unzip. Iteration is their ability to quickly iterate and do their job. You might use something like Canary deploys, as we were talking about before, to help them with that. So these two were pretty much the only things that I saw in like other developer experience engineering frameworks that I saw was keep them immersed and reduce their cognitive load. Errors and forgiveness, another two principles. Errors is obviously the state of something's gone wrong, it doesn't compile, the database connection is down. That shouldn't be catastrophic. Errors should in fact be treated as expected, because they are. If it's, whether it's a developer or an LLM or the system itself, something will always go wrong, and you have to forgive that. That has to be easily worked around. Don't forget things like backups that also come under this. Like if backups are, if an error happens in the future, I can forgive it easily because I'll just roll the backup. This is our last big one, right? Is highly flexible systems are always less usable than tightly focused ones. So I've got a great example here of my presentation remote. It's got a next button and a pointer button. It does its job, but I couldn't then go and edit the slideshow. The examples up there, I've got like the control panel of a desktop operating system versus a media player, which anyone should be able to pick up and go music play. So I'm going to use an example here. A pattern that I quite often see more than I should is what I call AWS as the platform, where you basically set up some sort of template of, you can make a repo, you can put Terraform in it, and then you can use Lambda functions, API gateway, DynamoDB tables, whatever you need to do your job. So when we do that, we are putting our developers way down this end of the flexibility usability trade-off. So back to our 3 C's, what would we give this in terms of consistency? Did someone say 0? Yeah, so you're not going to get any consistency, right? Every developer is going to approach this same problem completely differently. You're giving them a massive amount of control. You could potentially introduce some constraints, but you're pretty much pushing the boulder uphill. Like you're starting from a bad system and trying to improve it. So you're way down here in terms of the triangle.
Taking away their toys, you start introducing constraints.
Yeah, but you're gonna, if they're used to that much control and you start introducing constraints, they're not going to be happy. And you'll also have systems that already break those constraints. So what could we use instead of AWS as the platform? If we really want to do serverless, because serverless can be a good workflow for certain things. Kubernetes, yeah. I was going to say something like Knative or OpenFast, where you're giving them the ability to run code, a queue, some sort of API gateway, and a database. So you're giving them consistency because they've got to use those 4 tools. You're giving them constraints of they've got to use those 4 tools. You're giving them, I would say, 80% of the control for 20% of the the complicatedness. All right, is it time to talk about Kubernetes? I think I've been talking for like 20 minutes and I haven't mentioned Kubernetes once. So is it finally time to talk about Kubernetes? I've done that on purpose though, because I've hopefully given you guys the tools to analyze Kubernetes properly now. Why am I not going up? There we go. So where would we put Kubernetes on the flexibility, usability trade-off? Well, flexibility, yep. Again, context is important. So I've often heard Kubernetes described as the run anywhere cloud. So if we're doing the flexibility, usability trade-off compared to the cloud, where would we put Kubernetes? It's going to be a lot more usable than like giving your developers the hyperscaler, right? So again, just context is important, right? It's a lot more usable than a hyperscaler cloud. What would we give Kubernetes for consistency? Pretty good. Yeah, it basically forces us to use infrastructure as code, right? You can use kubectl run, but you're not going to have a very good time. Control. Pretty good. Yeah. Constraints.
That depends on the hyperscaler.
Yeah, that does depend a bit on, well, not necessarily, because there's also things like you've got like network policies, you've got resource limits. It's giving you, it's also constraining you into using its own YAML format, so you can't just run whatever you want. So that's, I guess, the lesson. Yeah, so that's pushing it more towards control as well, I suppose. So that's, I guess, what I'm trying to say is that's why Kubernetes is such a powerful sort of, and dare I say, good system, is because it's pretty good balance. It's sort of somewhere here from what we've discussed. It's making a pretty good trade-off between these three and the flexibility, usability as well. I think we're a bit pushed for time. I do have more. Let's do one more. Where would we put like a platform as a service, like Heroku, Fly, something like that? So yeah, so we're going to trade. We're trading some flexibility for a fair bit more usability, right? Let's bring your container, and we'll figure out the rest. What would we give it for consistency? Pretty high, yeah. And sort of you get the consistency of like the word, like runtimes or whatever as well. Control, maybe we're giving up some control. Again, I'd say the 80-20 rule applies here. We've got 80% of the control for 20% of the flexibility. Constraints, maybe a bit higher. We might be sort of more towards that way on the triangle if we use something like that. Yeah, so I've got a couple things to recap, and then let's go through like a recap and then time for some questions. So as I said, I'm independent now, doing cloud and DevOps and SRE, but through that lens of making something that actually works for the people who it's supposed to work for. If anyone's seen this presentation and gone, wow, I'd love to be a developer experience engineer, please hit me up. My email's there. If anyone's gone, wow, me or my customers or my friend would love a DevOps developer experience engineer, also hit me up. So to that end, I'm pretty excited to announce the first product to come out of that, this kind of whole thing. Ingressive Cloud. So as you know, the Nginx Ingress controller was completely retired not more than like a month ago. What I've essentially done is build like a cloud platform that does that for you. So we manage your DNS, your certificates, and your load balancer. Anytime you want to do ingress on Nginx, there's like 4 different tools and things that you have to balance. This just replaces them all. We've got a little connector. The traffic comes in, goes to your service. That's all you have to think about, and then just build your app. Yeah, it's up there. 6 principles. Does anyone remember all the things we covered today? What is
80-20.
80-20 rule. What's our nearly full basket? Cognitive load. What is our 3 C's, the important one? Consistency, control, constraints. What is our alarmed but happy computer? Errors and forgiveness. Yep. What is our complicated thing? Yep. Flexibility, usability, trade-off. And what is our very engrossed person? Yeah. Yeah, flow state's a good way to remember it. Immersion and iteration. So if you're going to take a picture to remember the talk, now would be the time, I think. Is that everyone quiet? All right, so question time, and there's my LinkedIn there if you want to hit me up. I'll head to Good George and maybe get a joke or two if anyone wants to join in on that afterwards. If you didn't maybe get to chat to people as much as you wanted before, that might be an opportunity. Yeah, anyone have any questions? Yeah.
In terms of IDPs, like what have you used?
IDPs,
Internal developer.
internal developer platforms. Let me think.
Things like Backstage, OpenShift.
Yeah, I tend to use, my thing is the 80-20 rule again, right? Developers spend, now that they're using LLMs, they spend 80% of their time in their IDE and probably 20% of their time in GitHub. So I generally use Kubernetes and then Argo CD. GitHub Actions builds, tells Argo CD there's a new version. If anything goes wrong, like all the logs are there in GitHub where they expect it. I think if you build I think, if I say they're spending 80% of their time in the IDE, 20% in GitHub, that means they're spending 0% of their time looking at the dashboards you set up for them.
I guess, so IDP is like Backstage, for example, is the interface. It's like, it's exactly what this is, development. It provides that front end of monitoring, deployment, coding. It's just this IDP.
Backstage, yeah.
There's a good website, IDP or Backstage.
Your project updates that you wrote. For example, if you're developing a lot of other application, Java or .NET, create a template and you can start using it, and also enable developers to figure out which service is owned by another. Even like that kind of like discovery.
It's basically a framework for developer experience, really. So like it has all these modules that you can just like plug together and you build your developer experience.
I find it horrible.
Yeah, it can be, but you've got to build it.
Yeah, maybe that's why I haven't used it.
Yeah, it goes back to the point about control, who controls what and what.
Yeah, that's why I think I like to optimize for, you can never assume that people are going to remember to fill out a wiki or own the services in the platform, or that's kind of what you have to do instead. You have to make that automatic. Any other questions?
Yeah. Or evaluated Backstage, and it's like Spotify. And my way of thinking is just go with whatever works for you, and because these are like, let's say, Port.io is a very sophisticated IDP. It's about $1 million for a 2-year license, and it's just a single pane of like nice UI that integrates with things. Call it OpenClaw.
And you can build your own with Power Board code. 10 minutes anyway.
In your framework, I don't know where this maps, but my idea of keep it simple and do whatever works for you. If Bash works for you, and you have a small team, go for it. You don't need code.
Yeah.
That's my view.
These sound like tools that are designed for like a massive workload that I think no one in this room actually has, like from the sound of what you guys are saying.
I built a company on this concept.
Yeah.
Thank you.
Yeah,
It's pretty important.
yeah, it's not throwing shade. I was just saying it sounds like a massive tool, and this framework's kind of thinking about what you actually need. Software development.
If you want to use, let's say, some agile, like, let's say a team uses agile, how do you embed this?
We've got immersion and iteration is kind of what Agile's hoping to enable. That's what Agile is hoping to be, right?
How will this work? So we have to frame, let's say, the stand-ups of the 6 principles. So the architect needs to embed the principles in the design.
Yeah. I have sort of focused on the developer, like what a DevOps engineer or something would be, so someone like within the team when they're setting things up. I do think it's kind of when you are having your sprint, you're trying to encourage immersion and iteration. When you are deciding what bugs to pick up and what tickets to pick up, you might use the 3 Cs. You might have a ticket like allow users to change their own address, and then you say, well, what constraints would we apply? It has to be a valid address. How would we make it consistent? We'll use an API to make sure that the address is real. Any other questions? Yeah,
Like
please.
you can cover a lot of stuff.
Yeah. I've said in one version of this talk, I was going to say you should be aiming to spend 80% of your time as a developer experience engineer, maybe 20% as the ops, like putting out fires. But obviously that's an ideal situation, and sometimes you do come into an organization or a system and it is just on fire. And whether you have the ability to go back and say, well, these are the things that are causing us pain and this is how we're going to fix it, that does depend on good leadership at the end of the day. Cool. I think that's pretty, yeah, unless there's anyone with a burning question. Yeah, like I said, I'm going to head down to Good George if anyone wants to join me or anyone wants to socialize some more.